Uh, Did you guys have a good time at the party last night? Good, good. Our next talk is by Robert Rowley. It's called An O-Day in the Life of a Security Researcher.
All right. Can you guys hear me? Yeah, that sounds good. I'm gonna move stuff. All right. Thank you all for waking up and being here and nursing your hangovers with croissants and orange juice. I'm gonna go ahead and do the talk. As DG said, this O-Day in Life Security Research is kind of like a walkthrough how I deal with my work as a security researcher working for TrustWave in the Spider Labs department. A lot of what I do, hold on a second, I did not have my thing done right. There we go. A lot of what I do in this talk is basically going to go through some popular vulnerabilities in the last year, talking about Ghost, XML RPC, and something I like to call smelly authentication. Then it's the end of presentation. You guys can go on and get lunch. So, like I said, my name is Robert Rowley. I work for TrustWave in the Spider Labs department. I've been around here for a long time. I've given a few talks here at LayerOne in the past. Who here has seen any of those? Oh, wow. It's like a lot of repeat people. Do you guys like me that much, or you just like had nothing else to do? Yeah, like I said, I helped run Irvine Underground. I started up a camp, which you guys can talk to me about if you're interested in doing that. It already happened this year. I've spoken a lot of times here. I hope that I'm at least entertaining and not full of FUD. Maybe if you see a lot of FUD spewing from my mouth, you can find me on Twitter at I am Lay and harass the shit out of me. I don't care. It's A-okay. So what's this talk all about? I'm going to be talking about kind of like how my day-to-day goes. CVEs come down the pipe. I have to kind of look at them, reverse engineer them. Who's done this? Who's like really looked at a CVE and tried to figure a proof of concept from it, but a proof of concept wasn't provided? Okay, so most of you are all in for a treat. Coincidentally, I'm going to be talking about PHP, Apache, and everybody's favorite content management system, WordPress. Who here likes WordPress? Who here likes WordPress because you use it? Who here likes WordPress because you hack it? This talk is going to cover basically this is not a WordPress scan talk. That's a cool utility, but I'm not talking about that. This is not a how to hack your WordPress talk. I'm trying to focus, this coincidentally, all these things are on WordPress. So I'm talking about my life as a security researcher, kind of the process that are involved, how to exploit vulnerabilities that all you have are a CVE. I'm just picking on WordPress for about the next hour because it was easy pickings. A lot of like what people like to say. Actually, I should also preface that I wrote this presentation about a month ago, which predated all the cross-site scripting, persistent cross-site scripting stuff that came out in the last month. So I'm sorry, I'm not specifically covering those CVEs. Those are like quite nice shutdowns of everything. And I had to cover also the people in WordPress and security. There's like two aspects. The WordPress community likes to say that core is secure, and they like to say it's just the plugins, just the themes, it's not our fault. And the security community just basically likes to say everything is insecure. I've never used it. Nobody ever upgrades. I had a bad experience. It's like oil and water, these two groups. So it's kind of interesting. Like I'll kind of describe some of the comminglings. I've spoken at WordPress conferences. In fact, I'm wearing a WordCamp T-shirt underneath this. And it's really interesting how that group kind of fits. A room about this size that basically have this one table right up here, like interspersed throughout the entire crowd. That's all the people that would show up for a security talk at a WordPress conference. And then specifically at the Phoenix one, they were tearing down the stage around me because as I'm trying to finish a security talk, because they're like, oh, you have nobody here. And I'm like, this isn't my fault. They also had open Wi-Fi, like insecure Wi-Fi for everybody there. And I'm like, that's bad too. I try to tell them this and they're like, nah. People will figure it out on their own. I'm like, no, they don't. This is why I'm a security guy. And this is why I'm here as a security guy, trying to tell you guys. So let's go into Ghost. Who knows Ghost? The get host by adder or get host by name vulnerability came out 3 months ago or so. It's pretty big. I wrote a quick song about it. It's called I Was Hacking with the Ghost. It was the cover of Tegan and Sarah. I said, please pop a shell. So CVEs come in. In my work, I wake up and I get a coffee, and then somebody somewhere who wakes up earlier than me, he's already heard about the vulnerability, and they're freaking out. And they're like, "Oh my God, do we have coverage? Like, what's going on with this?" So we look at the CVE because that's where obviously NVD, we get all the info we ever need from that. And this is what it looks like: a heap-based buffer overflow and underscore NSS hostname digit dots. I'm falling asleep. I have to get another cup of coffee by the time I read this. It has exactly no information. There is no proof of concept. There's no information. So while everybody's freaking out and demanding that I write some sort of vulnerability detection for this, like remote vulnerability detection, I'm just basically going, I have no idea what I'm doing. I kind of just want to hide and go to Starbucks and, just drink a latte the rest of the day. But nope, not happening. So we had to find some way to detect this. And as I mentioned, I kind of pick on WordPress. So I found vulnerability in WordPress that exploited the ghost vulnerability, which it lived in glibc, which is really hard to detect over the network. So you had to find a service or a process that was going to use the glibc request to do a get host by name lookup. Who can think about what component in WordPress does this and kind of can do this at any point in time? Yeah, did you read the blog post? No? Shut up. You're cheating. So, yeah, basically, XML RPC, you tell a site, hey, I really liked your post. I posted about your post on my site, so you should give me a ping back is what it's called. It's very strange terminology. So you basically tell it, yeah, I posted about you on my site, and what it does is it actually does a lookup and it'll request your site's information just to verify that the post is there. But in doing so, it'll do the lookup of the domain name. And that's where you can force WordPress to do a DNS lookup, and that's where you hit glibc's get host by adder function call, and everything goes downhill from there. So this was the slide of who thought it. This is what Vis's comment was. Thanks, Vis. Ruined my slide. Any questions so far? So this is also my quick little foray into how to get Metasploit credentials without trying. So some people were talking about XML RPC, and turns out I had pre-existing code that attacked XML RPC. I'll go into it shortly. So I basically grabbed the pre-existing code that I already have that used an attack against XML RPC and just dumped in, basically this is the code, this is the attack code. I wrote it and we published it. Basically, we just get the URL to attack. The malicious host is 0 times 2500 times, just really long host name. And that's all you needed to do to compromise this. You dump that into valid XML that you send to XML RPC. So it's just dumped into, that's actually not correctly how it's supposed to look like. I just dumped it into both points because I didn't care. And so you just dump 2500 characters of 0, or basically a really long host name, to it, and then you make the request at the bottom where you do the net HTTP start and all that stuff. It just looks for the response code. If it responded back as a 500, that means you're vulnerable. If it didn't respond back as a 500 or look different like that, you can pretty much assume it's not vulnerable. So that's pretty much, so we released that, and this is what it looks like this is how we validated it in the host logs. So it basically dumps, it causes PHP to crash outright. And most people really didn't get very farther than this. It's too hard to actually get a shell return from this. It was mostly very easy to cause processes in Apache to not function right. And everything fails catastrophically. But from my perspective as the security researcher, and really with the tools that I work on for Spider Labs and TrustWave, is to detect, are you vulnerable? Did you fail to apply this glibc patch? And the fact that I can do it via WordPress to find out when I made your PHP process or your Apache processes or Nginx processes crash because of a really long hostname, then I have validation. Then I can send it to you, send it to the pen tester who's going after your network, and he can keep going down that route or not. So that happened, and so I basically go up and we write a blog post, because that's what we do as security people. The people who released the vulns, obviously, that was Qualys, and they had to go pay the designer for the logo and the custom domain name. But all we have to do, what I like to do, is just the blog post. So you write a blog post, talk about glibc. While they were writing the blog post, I was busy learning the chords for Tegan and Sarah's hacking, or no, I was walking with the ghost, so I can say that I was hacking with the ghost. They write it up, and then this happens. Somebody named, shoot, I don't have his name. His name is somewhere on here. It's like Stinky Farts or something. It's a really inappropriate moniker. I really like the fact that it was somebody with the name Fart in their moniker referenced me. It's Todd BR7, but so this happened, like boom, Metasploit module that basically used our published POC that was in the blog post, and boom, right there is my name, first on the author list. I'm like, huzzah, I have Metasploit credentials without even trying. Now time to update my resume because now I can say Metasploit credentials. I didn't write a damn lick of code. So what have we learned? Life is full of free ice cream, pumpkin spice lattes, and puppies. Everything is great in the security field because everything you do, you get all its credentials and you get all its validation and authorships and are all properly resourced back and forth, right? Is that what it is? There's some grins and groans. So moving on. It's basically that was like a day. It's basically how it works. Everything is all happy, fun, lattes and puppies. I'll pick on XML RPs to see some more, just to throw some more vulnerabilities here into this talk. Who knows about XML expansion attacks? Basically, you nest values and link backs to another entity within XML. So basically, in here you say lols is just the string lols, and then lols2 references lols a bunch of times, and then lols3 references lols2. So it's a exponential growth of your memory usage for anybody who's trying to read in this data. And you don't have to send 200 megs of memory XML. You just do back references. So you're only sending a few kilobytes of XML, and it's like, it starts growing really big. Easy way to eat up a lot of server's resources. Again, reusing the XML code that I had earlier. Basic same idea, just dump in the attack payload. A lot of repetitive rinse, wash, and repeat, get more coffee sort of scenarios where they want to make me write new vulns. Another attack is the XML pingback attacks, where these are, who's familiar with the XML pingback denial of service attack via WordPress? That was fun, where you can tell one WordPress site, obviously they don't validate who was saying that they posted a post, but they do make the request to check if the post is there. So if you have a bunch of WordPress sites, you basically say, yeah, like I have a list of 100. I'm pretty sure everybody can find 100 WordPress sites on the internet, or a couple thousand, or if not 10,000 WordPress sites. Oh yeah, we all, Google.com just totally linked to you, and then they'll all make requests to Google.com, and Google.com will get a flood of requests from not who the originating attack source is. Another way to do this is kind of fun. You can use this as a network scanner. Basically I would recycle the exact same code that I was using before as well on these pingback attacks. Obviously detecting a denial of source, if you're open to being a denial of source, it's kind of a pain in the ass. But to do turn this into a network scanner is pretty interesting. You just change the host and port for the domain name that you're saying ping back to this, and you wait to read the timeout request to see if it's a really quick response. That means that port's probably open on the internal service because it responded back with like, this is an HTTP, what the fuck are you doing? If it's a really slow response, then you can validate that port probably isn't open because it sat there waiting for the timeout. So again, you just recycle that old code. It's pretty easy to recycle old code, dump it in, make new attacks. Everything's peachy and hunky-dory, and you get, like I said, puppies and pumpkin spice lattes. By the end of this talk, I'll probably call them puppy spice lattes. So getting into what I like to call smelly. Anybody know what I mean by when I call smelly? Something smells funny. Besides, the bathroom or my room this morning? No? All right. Basically by smelly, I mean something looks off, something looks weird. I also like to call it fucky, like something's fucky here, but I don't want to put fucky up here, so it'll just be on those that remember to pay for the recorded soundtrack. You hear me say fucky all the time. So smelly authentication or fucky authentication is a CVE that came out. This actually came pretty slow. About a year after this CVE came out, it was against WordPress. They said there's I forget the exact verbiage of it. I should have had a slide of it, but it was really indirect. It was like, yeah, when the user clicks log out, they don't actually get logged out. All it does is delete the cookie on the browser, and you can just, if you had that cookie saved, you can just regenerate it or basically put it back on the browser using any cookie manager software, and it still works. The cookie always works, no matter how many times you click log out. That cookie's always valid. And that was their big thing. They were like, oh, session replay or something like that. If the cookie deleted, it's still valid and somebody else could log in. But that didn't seem right to me. That didn't seem like that was all that was there. So I keep, session replay attack is a la Fire Sheep. It's part of the OAuth top 10. So really, if it's part of the OAuth top 10, you really have no reason to fuck that up. But yeah, I kind of looked into it because something seemed off. It didn't seem like that was all that was there because it had been a year since the CVE had been released before it came across my desk, and this is luckily something that nobody was freaking out about, and there were no logos, no custom websites about it. So I was like, all right, let me look into this, and I actually had the time to kind of look into it some more. I didn't just like quickly make a test and be done with it. So I started digging into everything, and I didn't know why it had been released yet. And the notes that I could find was basically the developers from the WordPress team were going, this is more complicated than you can do. We can't just fix it like that. Like your recommended patch, they had a patch. Like somebody submitted a patch to their SVN repo. Like we'll just do it, and they're like, oh, you don't understand. We can't do it. And people would actually I actually contacted them and I said, hey, this is still valid. Why is it still valid? It's a pretty bad vulnerability. WordPress users don't tend to think to use secure Wi-Fi, blah, blah, blah. They're like, oh, that's not our fault. It's not a real vulnerability. They should be using HTTPS instead. But yeah, all your sites, because you can't figure out auth or session management, everybody has to pay for a cert. So it's not, they were saying it wasn't their fault, it was the user's fault. So I kind of got to dig into it. So I'm going to walk through the process of what I found as I dug into it. And this is where I get really in depth, not just replacing code, but rewriting my own vulnerability and kind of amping up the attack surface against WordPress over about a year's time is what this took. So I considered it game on. They just told me if I came to them and I said your sessions are broken, they're like, this isn't sessions. You don't know what you're talking about. These are auth tokens. They're like, you guys are jackasses. So this is it. This is the auth token basically. WordPress is WordPress something underscore is the cookie name. The path is obvious, and then there's this value down here, the admin, and then what is, if you look at it right, that's a timestamp. That's a standard Unix epoch timestamp. This is magic value. So let's get into what this cookie name is. Who knows what the cookie name is offhand? Like how to generate that? Nobody? Oh, you guys are all going to learn a little bit. This is hardcore stuff. You'll never be able to guess this. So hold on to your panties. If auth cookie is defined, basically this is just basically defining some hard values. Basically, if it's not defined, define it as WordPress underscore that cookie hash. What is this magic cookie hash? All right, this is a global in PHP. It's a cookie hash. It's the 8.1 whatever it is. Never be able to figure that out. Oh, here it is. Here's what if cookie hash isn't defined, get site option site URL. So get the site's URL and then MD5 it. Hardcore stuff, guys. I hope everybody's understanding what's going on here. So that value, that cookie hash, that you're never going to be able to figure out because it's super duper secure, is an MD5 of the site's name. I don't even know what type of security that is, but I guess the terminology again is fuckery or fucky. Something's fucky with that. That isn't how you do security. I will be sure to sign up as the first person in line for WordPress security, like WordPress developer, secure developer certification, because if this is the bar, I'm good. MD5 that. They'll never know the site name past MD5. All right, so that's the first part. That was easy. Back to the cookie. Path, I'm not even going to talk about it. That wasn't an attempt at anything. And it wasn't a bad attempt, so I can't make fun of it. It's about what a path should be. But let's go to that value. So I told you the first part, I mean, it's obviously separated by pipes. All right, first part, I mean, at least they didn't do a PHP object or a serialization here. So I can pretty much break it apart by looking at it. Username timestamp, that's easy. Magic values, that's the key. If we can get into magic value and I can figure out how magic value is generated, then I can start seeing what was going on and why is it that these cookies are being able to be replayed? Why is it so impossible for the WordPress developers to apply a patch, which seemed like a reasonable patch? And why aren't they using sessions in a database like every other site on the internet that may basically manage the sessions properly? Because then you can create and destroy sessions. The logic for that magic value is in pluggable. This is just one of the files in WordPress includes. The function is generate auth cookie. 4 lines of code basically. Like, again, hold on to your panties. 4 lines of code here. Passfrag is a substring of the user's password. So it's after the 8th character, 4 digits after the 8th character. We'll come back to this at the end. There's extra credit for those of you in the audience that already know where the fuckery is. The key is generated by using this WP hash algorithm function. and sending in some information, basically user login, pipe, the passfrag, which is an unknown. User login's known, passfrag's unknown. The pipe character, expiration is known. It's actually controlled in the cookies value. And then scheme. So what we don't know is so far passfrag and whatever this WP hash function does. So let's see what WP hash function does. Let's go in here. All right. Again, this is just later and pluggable. WP hash takes the data. That's what we know. That's what we know is being passed to it. We have almost all the data except for that passfrag. Scheme is auth. Well, thank you. Or by default, it's auth. It's a salt of WP salt from the scheme. All right, and it returns an HMAC using MD5 of the data salt. All right, good. They're using salts. That's awesome. They're getting somewhere there. But let's see what's WP salt. WP salt. I'm kind of skipping ahead here because their code was all convoluted to validate if it exists in the database. But basically, WP Salt for 90% or more of WordPress sites out there pulls the strings from the WP config file for various keys. So all the secret salts, all the keys are located, like I said, 90% of WordPress sites for performance purposes, it's in a file called WP config. This is also why that file WP config, if anybody's worked with a WordPress website, all the values in this are you need to fucking change this. If you don't change them, then we know what the value is, and it's you need to fucking change this. Never mind the fact that, and this is where it gets kind of weird, and there's a little bit of fuckery or a little bit of fuckiness, is the values, if they don't exist here, they'll generate them and put them. If they were blank, they'd put them in the database, and they probably should live in the database, and they automatically generate them and dump them into the database for you. But for some reason, I presume for performance purposes, they really rely and they really want people to dump them into this WordPress config file, which I'll get back to later why that's a bit of the problem here. Anyways, we know that that's the salt. Sorry, double slide going on. So going back to that 4 lines of code that we got to understand that I just walked you all through in about 4 minutes. Look at my clock. All right, yeah. Password fragment. This is an unknown, but we know it's part of the user's password. WP hash is just the secret salt from the WP config file, basically MD5 of that. So that's how you gain the key. And then they just use hash HMAC all over again with another MD5 using the user login, expiration of the key. The key was basically the hash. So it's like what we don't know here is the key, but we can get it if we knew the password fragment and that secret salt. The timestamp is known because it's part of the cookie. And when you basically jam all that into a couple hash HMAX MD5s, boom, you generate what the cookie is, and we know what the magic value is. Once you can generate one of these cookies, you're authenticated. You don't have to pass any validation that you knew the password at any point in time on this thing. You didn't have to go through the user login process. If you have this cookie, you are in. So I talked about those 4 characters of the password and using substring. Those are finite. Those are only 4 characters. That's really what the crux is here. The secret salts are absolutely unknown, but there's ways to figure those out. Those are ways to tease those out of a site. And the timestamp is absolutely known and controlled. So what I did is when I first looked into this, it took me a couple weeks in my free time, and I just pieced together a post-compromise scenario. So if we can get to all of this data, right, it's kind of weird to say post-compromise scenario, so we're already broken into the site and we get all the data we want. But it's kind of neat to say, yeah, I already got into all the data I want. But all I'm going to do is run this code. Basically, it just dumps everything. It pulls in your WordPress config file, so I know all your secrets. And I promptly set an expiration date myself because it's controlled by me. And all this code does is runs through, grabs all the user IDs for a site, and generates a valid auth token that expires in 100 years from the time that I wrote this code, which was 2013. It all expires in 100 years, and I say, whatever, I can walk away. And as long as you didn't see any evidence of the compromise, you'll never know how I'm logging in, because I'm always getting back in because I have all your secrets. Or I had all your secrets and I generated a valid key. So it gets in, you'll never see anything in the attack logs that has a valid attack that happened, because it just looked like the admin logged in. In fact, it looks like the admin was already logged in if you look through the logs correctly. It's just the admin accessing the site and doing whatever malicious activity. So it would make really difficult for forensics to ever figure out what the fuck was going on, because again, like I said, no auth process was taking place. It's just somebody started accessing the admin panel, just did everything they wanted to do. So I released this and I did a blog post. in 2013, and if you noted, the CVE was from 2012. So a year after that CVE came out, and it was still vulnerable, I released this, and I talked to them, and I said I warned them I was going to do it, and they didn't. They honestly really didn't care. They kind of went on, and I was like, all right, all the puppies and pumpkin spice lattes in the world really didn't make up for it, or they didn't come up pouring into my office that day because it seemed like nobody cared. So as like the months went on, I just decided I wanted to fuck some more around with this. So, and I really wanted to show them that this could be a potential attack because there's some critical failures here. All you needed was a secret salt. The secret salt is the key. That's the big chunk of data that I'm never going to be able to really guess or brute force. But the 4 digits of a password, I can probably brute force reasonably fast. The way to get this would be SQLi if they existed in the database. It's weird, you already get a higher level access then, but maybe you only had a select or maybe you had access to the backup of the database. They rarely change these salts. These salts are a complicated thing for a WordPress user to change, especially if they're especially so if they're in the WordPress config file, because then they have to open an editor and their website and they have to type in a bunch of characters that are a valid salt string. So file disclosure is also a great way to do this, where let's say they had a backup copy of it, a backup copy of the website, something that didn't execute the PHP, like if you put a .back or a tilde or .swap file. If anybody remembers the disconnect camp CTF, the .swap file was the crux. Many people didn't check for those. Or even a Git repo or SVN repos, those things sometimes won't, they'll basically give you all the file's contents and they won't parse the PHP. So boom, if you get that secret salt, if you tease out that one little piece of information, then all that is relying on this site's auth tokens from not being generated maliciously is up to 4 characters of the user's password. And this is why I say up to 4 characters. Who's here familiar with substring in PHP? If you give it a string, let's say I did a substring of the word password, and I was just going to echo that starting after the 8th character. Coincidentally, password is 8 characters long, and I wanted the next 4 characters. Guess what PHP returns? Nothing. If you did password 1234 and you did everything after the 8th character, it returns the 1234. Everything after the 8th character, which is really where the fault here was. And I think that was a huge oversight in the fact that they completely forgot to consider that most of their users probably don't have an 8-character password at that. So most of the users, that secret password part, that we finite numbers of up to 4 characters, is probably nothing. It's probably an empty string. So once I know that you're secret salts, I'm just basically in. So I considered it mostly worthless. Who considers that strong? Again, if there was a WordPress security cert, like developer, like security, like course, I'd be all over it. We'll just do random string. It can return 0. I don't care. Let's not try to reroute over it. Let's not try to mangle it. Let's not even do more than 4 characters. Just 4 characters. Not even the first 4 characters. So I released a proof of concept on this. Again, it's really similar. I set some base values, expiration, which I control the entire time, target domain, some site, whatever. User is admin, so you'd have to know the valid user, which again, 80%, they always say don't use the admin account. 80% of them have an admin account. I'm pulling these statistics out of my ass, but they're pretty safe to say. If it's not 80, it's 85%. These are the auth keys. These are the things that you're going to have to be able to tease out of the site using another vulnerability like a file inclusion or file disclosure. So a file disclosure can turn into full site compromise in this scenario. The cookie name, again, we knew that. MD5, big trick, MD5, remember. Cookie name logged in, just WordPress logged in underscore, and then remember, MD5 is the site name. Let's not forget that. That was the thing that we'll never figure out. Then set the target value. This is the heart of the code. It's not really all that, it's a whole lot of code up on the screen, but mostly it's because it's a bunch of nested for loops as I start iterating through every potential character of those 4 characters of the user's password. Like I said, the pool size is pretty big. It starts like 64 and it goes up to like basically like 16 million potential requests that are going to be made. And what it does is it basically generates this cookie, and it starts with an empty string. So chances are, it's guaranteed that if their password was 8 characters or less, that first hit will just work. I like the thing popped on that. But yeah, the first hit will just work. And the the fragment was an empty string, and it starts iterating through them. Chances are, oh, okay, if they have a little more security, you'll have to iterate through all potential 1-character cases and then 2-character. It'll actually be like the Hollywood version of password cracking, where it starts locking in characters. Not really, but I should have done that in my proof of concept. Instead, my proof of concept is really just a PHP string. I forgot to mention, the last bit of this, it actually does the request. So it sets the cookie in curl and then makes the request to the website, and then it responds and it looks at the response to see if there's evidence that that's a valid login. It's like, the login link at the bottom of the WordPress site goes away and it becomes hello admin or something like that. And this is basically what the actual concept looked like. I should have done more razzle dazzle, but I'm not into the razzle dazzle. I just make the code that works. This would be a valid cookie. This is probably a valid cookie for one of my websites. So you guys want to take a picture, you can find my website. It's a cookie that expires in click. Let's wait for the flash. Yeah, I don't care about this website. It has been compromised because I'll guess what the password is password. You know how I get around that? I have 2-factor auth. Just by enabling 2-factor auth, all the tools that were attempting to send a brute force password, like they're actually trying the old school way of admin and choosing passwords, right? They're trying it the old school way as opposed to this cool new slick way. When they were trying, you can obviously see it, and it hits the sites a bunch. Like this is the normal brute force attack. You would see that all over the log, so there'd be a bunch of post requests to the WordPress admin page, like login page, the WordPress login page, bunch of post requests. And this actually caused a huge problem. I'm segueing because I've got about 30 minutes left, and this is getting close to the end. So a standard brute force attack against WordPress. This happened about 2 years ago, I want to say. Who here recalls that? I have a story about that, and I got time. So this, you recall it. You're not raising your hand. I hope you're not having a stroke. So yeah, this may or may not be having a stroke with his lack of neurons, drinking too much. Kids don't drink. You don't want to be waking up the next day, going to a talk, and having a stroke in the middle of the talk. Toes. Yeah. What are the symptoms for somebody having a stroke? If they got like the stumbles, but the fumbles, no, that's actually hypothermia. So yeah, the standard brute force attack against WordPress sites. This is like a huge thing that happened a few years ago. This has an involvement on this because, well, it was the one time somebody bitching on Twitter added up to something useful. He's like, why are a bunch of sites hitting my WordPress login pages? What is this? And I said, I don't know, that seems interesting. So I actually wrote a custom mod security rule that watched for all these things. And I basically turned my WordPress sites into little honeypots. And the mod security rule would basically take the request and log all the data. So most sites in your HTTP logs, your Apache logs, you're just going to see post request to WordPress login. You don't know the post value. It's not like get request where it's kind of part of the URI string. So you just get this post request, you lose the values. But with mod security, I have access to all the data, like cookie data, post data, all the hidden data, server response, and blah, blah, blah. And I wrote a tool in mod security that would log all that to a file. So it would see your requests that were coming in, and it would just log these things to a file. So this was, I'd say, like 2.5 years ago, just to give some vague time frame on it. Because he bitched on Twitter, and I was like, well, I want to see what's going on. So I started logging all the username and passwords that they were attempting against my sites. And there was really interesting information. It was like Pokemon was a password that they were trying. Naruto was a password that they were trying. I was like, I don't know, who the hell do they think I am? Like, there's some BS like pseudo security like site that I just pound on all the time for like validating stuff, and I happen to have it on the internet just out of convenience. They're trying all of these passwords, and none of them were working. Because at the time, it was password, but I had 2-factor auth, and none of the brute force tools even tried that. This culminated about 6 months later from the little whiny tweet where I started collecting data, culminating into like this massive attack for some reason against all WordPress sites. And if you would have noticed, like some people were calling it like a DDoS against WordPress. And it was funny because any like boutique WordPress hosts or any large WordPress hosts or things even hosted like on the Automatic network, like the really beefy hardware was like fending off these quote unquote attacks, which really just brute force at requests. But all the shared hosting providers that It turns out their hardware was probably a little less tuned properly. Ended up basically start going down. Like they were going down hard. Non-WordPress sites were going down hard because the WordPress sites were getting attacked. It turns out the request that WordPress was making to the database when it was trying to query if the password was correct was eating up so many resources that just a standard brute force attack turned into a denial of service attack. And I'm sitting over here, thanks to this, and I have the exact list of the passwords that they were trying because I'd been logging it for like 6 months, and then it just suddenly ramped up. And it was easy for me to make a preventative measure for this because I could just blacklist those passwords as stupid passwords. Most people implemented something like a 3 tries and you're out sort of scenario, but they did it on like a firewall level where if they saw the same IP address keep trying to hit a WordPress site and they kept failing to get valid logins, they just blocked that IP address for a little while, which is all right way to handle it. But the difference between that type of brute force attack and this type of brute force attack is I have a cookie, and your logs aren't going to see the cookie at all. All your logs are going to say is me looking at me and my script running, and it's just making requests for your site's root path or your WordPress root, and that's it. And just making it work. I could even like customize the script a bit more, and I'm just like traversing your site really slowly as it goes through each time. Though, however, what I'm doing is I'm generating a valid auth cookie. And I include that auth cookie in my headers when I send it to you. And I'm looking back to see if the response has that little link in the bottom that says please log in, or if the please log in says hello admin. And once it sees that it says hello admin, it dumps out the cookie, and then I can come back later and look at it, and there I've got a valid auth cookie. So I think this is pretty good. I mean, with a little bit of sneaking some information, I can generate an reasonably undetectable brute force tool that looks like normal traffic, break into any WordPress site anywhere in the world. So right, time to bathe in praise. Yeah, no, that didn't happen. I wrote like multiple blog posts on this. I started harassing the WordPress developers. All I got was a lot of like crass harassment. I think even my boss was probably like, why are you working on this thing? Really, WordPress, come on. Everybody knows. Like, I contacted their quote-unquote security staff, which was really funny because I started like paying attention to their stuff, and they released a security white paper for WordPress where they say, and I quote, we have over 200 security developers. That's a lot of fucking developers working on security. Oh, fuck they're doing, but I guess, yeah, security developers, man, I was talking earlier, that course that they've got must be fucking hard. Did you fill in your name right? Maybe there's one guy just couldn't fill in his name right, and they just accepted all of them as security developer Auto 1, Auto 2. But I implemented the detection for this vulnerability in our in-house scanner, basically effectively Metasploit. We didn't release the code, but we did release those proof of concepts. Nobody from Metasploit really wanted to implement it in theirs. It's PHP, so I guess they were kind of worried about it. Eventually, it was great, and it was fixed in 2014 when they released version, actually WordPress, I think 4.2. All I was left was cold coffee and me filling up my now empty coffee cup with whiskey the rest of the day to just go to sleep at night knowing that this is how people sometimes take care of security or really care about security. I got no praise. I moved on. Like I said, that's just another day in the life as a security researcher. What have we learned here? There you go. Thanks. Sometimes thankless. Sometimes it's awesome and great. Sometimes it's just bullshit. But it's really fun when you sit around going, I can break into all of these sites, but I can't because, yeah, that would be illegal. So any questions, thoughts, concerns? Anybody watching the clock notice that I actually went kind of fast? Like I said, I warned early. If I get enough caffeine, I just go. Blah, 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 blah. I got a little Yorkshire Terrier. I'll start on the left side.
So were you emailing the researchers or
10 minutes, 20 minutes,
or what?
20. What? I was emailing the research. I was contacting them on IRC. Like I was sending out smoke signals. So like I know people in the WordPress community. Like I had friends. I'm like, dude, why is this guy being a dick? Like I'd email them, and I said Auto 1, Auto 2. That's one of the names of the people that responded to me was Auto, like Simpsons bus driver guy. I hope to imagine that he is that guy. And nobody really seemed to care. They seemed to kind of get stuck on this. You called it sessions, and it's not, and then they just shoot me down. What's funny is I didn't find the original CVE in this at all. Before me, And in the blog post that I write about it, I do give proper credit. I omitted the credit here just because I forgot it. But before me, there was another group. I think it was like White Oak Security, some sort of tree name security group. They're the ones that got the CVE validated by NVD or CSI or T. I forget who does the NVDs. I would know it. CERN? No. They do exploding molecules. Derp. I drank a lot last night. Coffee's not functioning. Cheers. But yeah, before me it was them, and before them it was this other guy who apparently his brother is one of the WordPress developers. So like, if through having a CVE and having a security researcher at Trustworthy Spider Labs going like, the hell, and like contacting, and like, they basically got tired of it, hearing of it, by the time it got to me, that they're just like, fucking go away. Nobody's going to actually compromise this. And it was mostly because the guys before me kind of stopped slow, kind of stopped short, and I just kept ratcheting up every couple of months. I'd release a little bit more of a piece of like here's a little bit of like that 7-course dinner of me compromising WordPress sites. Like, here's a little bit more of the attack. Here's a little bit more. I'm like, eventually this is going to go really bad until I see that you're actually fixing it. They eventually fixed it by adding a nonce, which is stored in the database, and it's a value that's a temporary value that's only created and valid for the time of the cookies. It's tied to the timestamp. That's all they needed to do. In fact, all they really needed to do is have valid timestamps in the database as well. They didn't need to generate new nonces, just saying this is a valid timestamp for one of the cookies. If you're generating your own timestamps, everything's everything's way off. One of the developers did kind of get back to me, and I remember his argument, like I mentioned earlier, was they should just use HTTPS. It's not our fault that they're not using HTTPS. I'm like, that's bullshit. A little later, the other response was, you don't know how much resource overhead this is. It would destroy so many WordPress sites. I'm like, no, like, it's probably worse that they're getting hacked. That's using a lot of resources. And then the other one was, I did the resource one, and it was, this isn't an RFC. We just follow the RFC, so the RFC has to be right. If it's wrong, it's wrong. We're not wrong for following the wrong RFC. Right? It's like who's the bigger fool? The fool following or the fool leading? They didn't care. They found ways to divert it. Some of the people that I talked to were really useless. Some of the other people that I talked to were friends of mine who kind of worked with the community. They were more understanding of it all. And like I ended up, like I say, I've given talks at them. I kind of know how their stance is. They feel like the security community is attacking them. Security community feels like they're ignoring them, which creates an animosity. It's oil and water, and they just don't jive together. And I come as nice as I can to be like, this is what it is. And look what I had to do. I had to basically tear it apart with proof of concepts that I'm like, I can break into sites all day long, as much as I want, as long as I can start, as long as I tease out this information, I can start popping sites. And they won't care until, well, basically I start doing that, and then their customers are whining because sites are getting popped and they don't know why. So yeah, that's the fun. Again, so another question.
So this is password substrating, imply that they're storing passwords in plain text in the database.
Oh yeah. The passwords are plain text in the database.
And the other thing that appeared quite fucky to me is if they're doing this like non-session thing for performance or resource reasons, they're having to hit the database anyway to get the password out. So
they're having to tease that information out anyways. Their argument, their argument is that they're already hitting the database. Why is this argument? They have 200 security developers, man. I got to argue every one of them, like in this battle of like an old 70s arcade system. I've got to go to every fucking boss, get through every level of the 200 security developers, till I'm after like the big boss, and I'd be like, I compromised all this shit. What do you want me to do? I basically ran out of quarters. It's good analogy. I ran out of quarters before I could get through all of them to really kind of make an impact. And by quarters, I mean resources. I didn't have the time to just keep berating them to make it fixed. All I could do is make the blog post and hope that it catches with somebody. I'm sure it kind of caught. I'm sure like backroom decisions and discussions kind of included my name as being the jackass who keeps talking about auth and calls it a session. Like the first blog post I did was called Jamming with WordPress Sessions. And they're all like, this guy doesn't know what he's talking about. We don't use sessions. They're like, it's auth, it's sessions. It's a valid token to get into your site. I don't care what you call it. It's broken. So I say also, what have we learned here? Just another day. Enjoy life. Get out. Enjoy life. Thank you all. Tip your waiters. Stay gold or something. If you guys want to talk to me, also, I got to pin the plug, which Datagram's not here, so they won't hear me say it. Like, yeah, TrustWave is hiring. So if anybody's here looking for work, hiring all sorts of stuff. I'll probably just tell you to go to the job Vite system because I don't even know what everything we're hiring for is. It's also should not be a surprise. Everybody in security is hiring right now. And anybody who wants to talk to me out of band about more of this the discussions that I've had with these pesky WordPress security developers, I can get quite animated. Thank you.